So we were solving this example and then we made this substitution. So dy over dx is equal to du over dx plus 2, du over dx plus 2, and then this will be u, so it will be u square minus 7. So it will be du over dx is equal to u square minus 9. So 2 will be go there. So this is a separable equation. So we can separate the variables. So it will be du over u square minus 9 is equal to dx. To find the integral of this, so we must factorize it. So you can write it like x square minus 9 as u square minus 9 as u minus 3 into u plus 3 dx, and we can make the partial fractions of this. So you may have used partial fraction method in your elementary algebra. So for example, if I want to make the partial fraction of this, so I will equate it to like this. Okay, so we suppose that these are the partial fractions, so but we need to find the values of a and b. So what I can do is I can multiply throughout by u minus 3 over and u plus 3, so the terms will become u plus 3 plus b is equal to u minus 3. So if I put u is equal to minus 3, then this will give me a into 0 plus b into minus 6. So the value of b will be minus 1 over 6. If I put u is equal to 3 over here, so it will be 1 equal to a into 6, u 3 plus 3 6 plus b into u is equal to, so a will be equal to 1 over 6. So it means that I can write this in partial fraction terms, 1 over 6 u minus 3 plus b, which is minus 1 over 6. So it will be minus 1 over 6 u plus 3 dx. Now, so 1 over 6 is common. Oh, now I can integrate it very easily. So it will be du over here. So 1 over 6. So integration will be log u minus 3 minus 1 over 6 log u plus 3. Okay, and then it will be x plus c. So from here I can say that 1 over 6 log u minus 3 minus log u plus 3, so it will be log u minus 3 over u plus 3, okay, equal to x plus c. So moreover, I can write it like this: log u minus 3 over u plus 3 is equal to 6x plus 6c. 6c is another constant. Okay, now take the exponentiation. So u minus 3 over u plus 3 will be equal to exponent of 6x plus c, which is the same as c times 6x. Okay, because e power c will be also a constant. Now what I can do is I can cross multiply. U minus 3 will be equal to c e power 6 into u plus 3, and then I take the u terms on one side and the other terms on the other side. So it will be u, and then this term it will be minus c e power 6 here, and then it will be 3c e power 6 plus 3. Okay, and now in this way I can find the value of u is equal to 3 into 1 plus c e power 6 divided by 1 minus c e power 6x. And what I have over here is now I can input the value of u as well. So what is u? So u, we already, before we assumed u is equal to minus 2x plus y. Okay, so I can put minus 2x plus y is equal to this value. And then finally y will be equal to 3 into 1 plus c e power 6 over 1 minus c e power 6. Okay, so suppose it is an initial value problem. Okay, where it is y 0 is equal to 0. So then I can find the value of the constant. So y0 is equal to 0. So 0 is equal to 3 into 1 plus c e power 0 divided by 1 minus c e power 0. So this will be, then that means 1 plus c equal to 0, so value of c will be equal to minus 1. So the particular solution for this equation will be 3 into 1 minus e power 6x over 1 plus e power 6x. This will be the particular solution. No, actually, well, it doesn't make any difference. Y is equal to 2x plus this value. This is the general solution. So, and then you must add plus 2x. Okay, this is the final particular solution. So in this way, in the substitution method, we have used 3 kinds of substitution. So if the equation is homogeneous, then a substitution of y is equal to ux can be used, or x is equal to uy can be used. Sometimes the second substitution can be used if the expression becomes difficult with y is equal to ux. Okay, so x is equal to ux substitution can be used, and accordingly this equation can be modified for their differentials. So the second substitution we used for the Bernoulli's equation. Bernoulli's equation. Okay, and Bernoulli's equation is the same as the linear differential equation, but on the right hand side of the Bernoulli's equation there is a non-linear y term in terms of y power n. So the substitution which is used in this case is equal to u is equal to y power 1 minus n, where n was the power in the Bernoulli's equation on the right hand side. And the third substitution is when you have an equation in which you have term like this. this kind of term, function of fx ax plus by plus c. So in this case, you use the substitution u is equal to ax plus by plus c, where b should not be equal to 0. Okay. So these three kinds of substitutions are very common for the solution of the first order differential equations.